Holy cow, they can't expect you to do this. Okay, you're an advanced student by now. You know that this is x naught, this is omega right there. Okay, we've got the mass. So the total energy is going to be 1/2 m omega squared x naught squared, right? So that's 1/2 times 0.551 kilograms, right? Times omega 2.31 squared, and then x naught is 0.16 squared, right? Okay, so if I do that, if I bust that out in my calculator, okay, 0.5 times 0.551 times 2.31 squared times 0.16 squared. Storage, I'm going to store that in, I'll store that in I. Okay, and that is the total energy is 0.03763 joules, not so many joules, right? Ta-da. That's this answer here. How do I draw those straight lines? That's amazing. Okay, and then what's its maximum velocity? The maximum velocity is just going to be V naught is equal to omega x naught, right? I'm tired of deriving that formula. Okay, so that's going to be 2.31 radians per second, right? Because that's our omega right there, right? Times x naught, which is this guy, right? 0.16 meters. So 2.31 times 0.16. Let's store that in J. And I get 0.3696 meters per second, which we'd have to write it like that, right? To like, yeah. Okay, so let's see. At time is 13.5 seconds. Find the position of the oscillator, the velocity of the oscillator, the kinetic energy of the oscillator, and its potential energy. Oh my God, how are we going to do that? That's like impossible. Okay, so A is just, we're going to use this formula, right? X is 0.16 sine 2.31 t. Make sure you're in radians. Okay, so I'm going to go 0.16 times sine parentheses 2.31 times and then 13.5 seconds, right? This is what I'm typing into the calculator. 0.16 sine, I can put a times in there because and then I'm going 2.31 times 13.5. Okay, let's store that in A. And the answer is negative 0.036621. Okay, meters. Yeah, so that's this answer right here. Okay. Okay. What's the velocity of the oscillator at this point? Well, I could find the speed of it using the v equals omega square root of x naught squared minus x squared, right? But I don't want to do that. I think what I want to do is use the actual velocity formula, right? Because notice that this velocity could be positive or negative, right? Okay, so for B, I'm going to say that V is equal to V naught cos omega t, right? So the formula for its position, there's our V naught, right? Okay, so it's going to be, where did I store that? I stored it right there. Okay, so I'm just going to plug in, right? So it's going to be 0.3696 meters per second, right? I'm using the unrounded value of this guy, right? Times cos, and then, you know, it's just 2.31, right? Right, times 13.5. Okay, so I can go that times cos 2.31 times equals 0.3598788 meters per second. All right, so positive, and that's positive. That means it really is going. When you use this formula, it will tell you whether it's going positively or negatively, and there it is. And it's going nearly it's going nearly the maximum velocity at that point, and that's because it's so close to equilibrium. If you look at that, it's 3 centimeters, 4 centimeters, 3.6 centimeters from equilibrium out of 16, so it's very close to equilibrium, right? So it's going nearly its maximum velocity, but not quite, right? Okay. Find the kinetic energy of the oscillator. Well, there's lots of ways to find the kinetic energy here, okay? Since we know the velocity, the simplest way to find it would just to be, okay, for C, okay? The simplest way would just be 1/2 mv squared. 1/2 mv squared is kinetic energy, right? So it's 1/2 times 0.551, right, times, let's see, this number here, right, 0.3598788 squared, right? So I'm going to square that number times 0.551 times 0.5, and I get 0.03566. 0.03566 joules, right, which is this one. Now, I know what you want me to do. You want me to bust out the fancy formula, right? That one also works, okay? But for that one, we'd use this position, right? Okay, so you could also use the 1/2 m omega squared x naught squared minus x squared, right? And that you'd use this position right here, okay? That would be your x naught, right? And then x naught would be your 0.16, right? Okay, I'm choosing not to do that though. Okay, so now then it says what is its potential energy at that point? Well, the total energy is this, right? That's our total energy. The total energy plus this energy equals potential energy, right? So for D, right, the potential energy is just the total energy, which is 0.03763 joules. That's this number not rounded, minus the energy that's in kinetic, right? So 0.03566, right? Okay. Minus that one there. Okay. And I get the answer I'm getting here is 0.0019715 joules, right? Which is this guy, right? So remember, potential energy is the difference between the total energy and the kinetic energy, right? But total energy minus kinetic energy equals potential energy, right? That's not so bad. Okay, it's bad.